Hello, and welcome to the Argyle CIO Leadership Forum. My name is Nick with Argyle, and it's great to have everyone joining us today. A couple of notes before I turn things over to our esteemed speaker. First, a quick reminder to stop by our sponsors' virtual booths at any time during today's event and for the following week. Our partners are committed to providing you with valuable content and a great overall experience. At any time during today's event, you can visit their virtual booths from the main agenda page. To ask questions throughout the session, simply type into the Q&A chat and we will address your questions at the end of the session. Now, without further delay, I would like to introduce our speaker, Tolgai Kizilelma, Director of MS in Cybersecurity Program, Dominican University of California. We're super excited to have Tolgai with us for a keynote presentation titled On the Edge in 2024, Exploring Cloud and Edge Computing. Welcome, Tolgai. Over to you.
Well, thank you, Nick. I really appreciate it. I like these virtual events. It's always a good learning opportunity from the comfort of your home. And I really appreciate everybody joining. Thank you very much. So we'll cover, cloud edge computing, useful use cases, benefits, challenges, and hopefully you'll get some value out of this short 30-minute or less discussion. So the agenda is, again, about cloud, network limitations, edge computing definition, benefits, and challenges, and future trends, obviously. So what is cloud computing? I think we've kind of got used to it, right? So the past 2 decades, we've been using cloud for so much, and the business is really benefiting from cloud, delivering services, products. So why, right? The question is why. There are a couple of things, obviously, which we all know. Cost is one of the main drivers. It's one of the key differences between the cloud computing that we've been doing for the past couple of decades versus the traditional IT infrastructure. That's the cost. It can be really much more cost effective than traditional computing because it eliminates the need to purchase, install, maintain hardware, software over a number of years. And of course, especially the users are charged based on the usage rather than a flat fee. That's also another driver. Scalability is another difference of cloud computing versus the traditional computing. It's really offering greater scalability than the traditional IT infrastructure. The traditional computing companies, really, they have to go through that procurement of purchasing additional hardware, software, in order to increase their capacity, add new features, meet the demand. With cloud computing, it is right on the go, on demand, and they can quickly, easily scale up, down as needed without having to make all those large investments. So that's really the CAPEX versus the OPEX issue. So it makes it really easier for companies to respond quickly to the changing business needs. Reliability, again, another difference in terms of how the cloud providers, service providers make their services, products reliable through their extensive network of data centers located throughout the world. And that's another driver for the businesses. Is important, obviously. Security. These cloud security service providers, they have thousands and hundreds of thousands of customers. So security is one of their priorities. They want to make sure the service and products that they provide is secure. So from that perspective, it is another benefit, positive, why we move to cloud. Flexibility, and that's really the final difference, is really providing users. There's that anytime, anywhere connection from any device connectivity. So that's that flexibility that allows users and their endpoint devices to connect and provide their services to their consumers. So there are these high-level cloud computing advantages and benefits that we've all been using for the past 2+ decades. So what are the limitations? Why are we making this transition? Why are we talking about edge computing? There are limitations, obviously. Bandwidth, latency, congestion. There are some of those. Bandwidth, as you know, is really the amount of data that can be carried over a network. Is usually expressed in bits per second. All networks have limitations in terms of bandwidth. And the importance of that is we want to make sure we provide that data transportation, right, between our business to the cloud. So bandwidth is another issue why we have to deal with and try to improve the process. Latency, again, is the time needed to send the data between two data points on the network. So we want to make sure the latency is as low as possible so that we get that response time, especially for sensitive applications. That's important. Congestion, depending on the type of internet cloud that you have, it's a global network of networks, the internet, and it has evolved throughout the the past 2 or 3 decades, obviously. But still, depending on type of connection, depending on type of cloud you have in place, the volume of data involved between two data points, it may not be as reliable as you wish, especially when you're creating that data on-prem, right? Versus your cloud services are on the cloud. There's that issue, and it's not 100% reliable, and the congestion might be an issue from time to time. So edge computing, that's really why we're having this. So let's talk about the edge computing a bit in terms of what it is and what it does, how we can benefit, the organizations can benefit from it. First of all, it's all about data, right? We generate that data. There's a whole data life cycle. So proximity to data sources, I think that's the main thing. Edge computing places computational resources closer to where data is generated. We have so many different types of devices, IoT devices, sensors, endpoints, right, in our networks that we use for our business, and they all generate data. And the proximity is important. This reduces that distance that the data needs to travel, minimizing the latency, improving responsiveness for those time-sensitive applications. Real-time processing is another important element. By processing data locally at the edge, edge computing enables faster decision making and real-time data insights, and is critical for applications that require immediate action-based incoming data, such as autonomous vehicles, healthcare monitoring, industrial control systems. That responsiveness, real-time processing is very important, and that's where the data is generated, created. Bandwidth optimization, we mentioned about the latency issues. So edge computing can reduce the amount of data that needs to be transmitted. Therefore, the latency issues reduce impact, and that's really is important. Decentralized architecture, unlike the traditional cloud computing, which relies on centralized data centers throughout the world, edge computing employs a decentralized architecture with computing resources distributed across multiple edge devices or nodes. And this decentralized the structure enhances the scalability, the resilience, as well as reduces dependency on a single point of failure. And of course, there's the data privacy and security aspects. You have ownership to a certain degree in terms of the data where it's created. You're not transmitting. You're basically protecting the against the threats when the data is being transferred. So that exposure reduction, I think, is critically important for the potential security threats during data transmission, especially when you have applications handling confidential or regulated data. So these are all high-level features of edge computing, and it's really important to know these. But then again, the main differences, if you want to cover them, it's all about this decentralized structure, the latency issues, low, high, in terms of the different latest technology emerging in terms of AI and the power storage consumption. Security is another important element. Where you store data. Part of the data lifecycle is critical. Scalability, that's also another element in terms of cloud has more advantages there. Power and all that, and edge computing is really where you create the data and low latency. So when you look at these from that perspective, it just makes sense as to why can we just not combine them so that businesses can really utilize and take advantage of the benefits so that they can create more value for their consumers, for their customers, for their users by improving their services, timely response, right? That's really the goal. That's what we're trying to do. So talking about the edge computing use cases and examples, I mean, there are many, obviously. As we mentioned, it's all about the data creation, data lifecycle, data use, share, retention. So the data lifecycle aspect is very important. Businesses generate tons of data And edge computing, in terms of the use cases, it covers different industries, applicable to a variety of industries. Smart cities, autonomous vehicles, as I mentioned, smart homes, healthcare is one big area industry, manufacturing, so far, like industry processes, retail again, another strong area where you can implement and get the benefits of edge computing. And again, there are all other different use cases that you can really look into in terms of where the data is generated, right, at the source, at the edge, and all that computes power, storage power of the cloud. And when you bring these two together, it just makes sense for the organizations to improve that value proposition. So let's look at one of the examples. I mean, you can kind of go through all these and you can make a case, but due to our time limitation. So what I like to do is really go through smart cities. And again, it's all about the data, right? Civic authorities, they are using edge computing to create these communities, smart communities, and run their roadways with the capabilities of intelligent traffic monitoring, controls, and there are all other things to build around these smart cities to make the citizens' life easier, right? The edge, it supports a host of areas within this broad category. It helps the civic authorities, such as traffic agencies, public transformation departments, private transportation companies, to better manage their vehicle fleets and overall traffic flow by enabling rapid adjustments to the traffic, and based on the data that they're receiving real time on the ground conditions. If there's an accident, if there's a work construction on a specific road, or the road is closed. So these are all the important real-time events that help the consumers make better decisions in terms of getting from point A to point B, and it's important. So looking at the different elements, tracking data, capturing data real time, impacts how the smart cities work. The public transit system, the municipal utilities, city services, eventually long-term urban planning, and how you can really integrate these to intelligent traffic controls, because nowadays there's so much emphasis on autonomous vehicles. So when you kind of look into this big picture, it just makes sense that the edge computing, where we have that data captured, right, from those sensors, from the IoT devices, and processed, analyzed, so that we can make those real-time, instant decisions, making the service and products we deliver important for our consumers, for our end users, so that they really get the most value from the use of our technology. The different vendors providing different technologies. So edge computing and the traditional cloud computing, how do we get them together, right? So we talked about data processing and aggregation. Edge computing, there's that initial data processing, creation, filtering. So aggregation at the devices or the gateways, so where the data starts its life. And then with the traditional cloud computing, there's all that summarization, the pre-processed data for further analysis, data analytics, long-term storage, large-scale processing. So when you combine these together, that data processing and aggregation is one area that we can kind of bring them together. Real-time decision-making, as we mentioned, edge computing enabling immediate low latency decision making at the edge, where things are happening, where the data is creating, especially for time-sensitive applications. And then traditional cloud computing is really the complex analytics, the machine learning, and predictive modeling based on the aggregated edge data, essentially providing the users of the data valuable service and products. Scalability and resource optimization. Again, edge and traditional cloud computing, they kind of come together, handling local processing and workload distribution to optimize the edge devices, which is edge computing, so addressing the edge resources. And then on the cloud computing, it's really the scaling of those resources dynamically and accommodating the fluctuating demands or the bursty workloads, right? Because that demand is important. That's one of the advantages, scaling up and down. Hybrid application architectures, supporting distributed applications, spanning across the edge of devices and cloud services is something edge computing does. And through the cloud computing, hosting centralized components of those applications for management, orchestration, and global accessibility is another way we can combine them, which is the hybrid architecture model. Data architecture, data storage and backup is really storing, creating data that's really frequently accessed and for rapid retrieval and offline operation. And then on the cloud computing side, it's replicating that edge data to the cloud for backup, disaster recovery, and compliance specifically, and long-term archival. And of course, the last is the security and compliance. We always have those two, security and compliance, go together. It's really enhancing the data privacy by processing sensitive information locally before transmitting to the cloud, so that you have a bit of security control there. And then on the cloud side, leveraging the cloud-based security services and identity management compliance frameworks that each major cloud service provider does provide. So benefits of edge computing is really about the value proposition, right? It's realizing the benefits by optimizing the associated risk. All businesses have those. And also optimizing the use of resources, limited resources, right, most of the time, and of course complying with laws and regulations. So that's really our driving, approach. That's how we look at things. And from that perspective, then it's all about different things we want to do. Edge computing addresses vital infrastructure challenges. Obviously, there are bandwidth limitations, latency congestion, as we mentioned, but at the same time, there are several potential benefits to edge computing when combined with the cloud services. So autonomy is one thing, right? So edge computing is useful where connectivity is unreliable or bandwidth is restricted because of the site's environmental characteristics. So that autonomy of where the data on site or where it's created, IoT sensors, is very important. Like you might have these oil rigs, ships at sea, remote farms, right? They're kind of out there, but they generate data. Eventually, they need to be transferred. So that's really one aspect in terms of the benefit. Data sovereignty is another element in terms of moving huge amounts of data. Isn't just a technical problem. It travels across national and regional boundaries, and it can pose additional problems for data security, privacy, and other legal issues. So edge computing can be used to keep all that data close to its source and within the bounds of the prevailing local laws and regulations. Like GDPR might be one element or example. Edge security, as we mentioned, is another area that that we can talk about. It adds additional opportunity to implement and ensure data security. So that allows us to do all those things. Of course, cloud providers have they provide IoT services and they specialize in complex analysis, those type of things. But cloud or data center implementations, how we you utilize their processing power, storage, that's all important. But the edge security is critical as well. So, and again, these are all the type of things. I'm not going to go through all of them, but at the end of the day, again, it all boils down to the improved scalability, cost efficiencies, which most organizations are looking for, right? And then security, privacy. They're really the drivers of the edge computing plus the traditional cloud computing and the benefits that we see. So there are concerns and challenges. Obviously, we like to address them. The benefits are there, obviously, just like looking at the glass half full, half empty. So benefits is one thing, but you have to really approach the issue from a data management perspective, from a lifecycle perspective. That's very important. Edge computing generates vast amounts of data locally, and that's really the goal, right? The data is generated there, and it does require efficient data processing, storage management, so organizations, they have to implement all these robust data governance practices to ensure the data integrity, security, compliance. So that's one area, a concern or challenge. How you do go through the data lifecycle, the data management, that's important. Interoperability and standards, because ensuring interoperability and compatibility among diverse edge devices. And we have so many different types in terms of IoTs and wearables, this and that, different industries using different, operational technologies and critical infrastructure. They're all different types, right? So when you kind of have all these things on your under your business, that compatibility and interoperability becomes an issue. And different types of platforms, different types of protocols can be challenging. So lack of standardized frameworks may hinder that seamless integration and scalability that we're used to from the cloud environments. Scalability and resource constraints, again, another issue might be a concern. The edge devices, they typically have limited processing power, memory, and storage capacity. Scaling these edge deployments to handle the growing needs, demands, the workloads, while optimizing, as I mentioned, the resource utilization, it does require careful planning and investment. So you have to be very, very careful there. Data consistency and synchronization. It is important when you maintain data consistency, synchronization across your distributed edge nodes and the cloud. It can be a very complex process, right? So you have the edge, cloud, and the data, because you want to get as consistent and synchronized data as much as possible for all purposes, but most importantly, decision-making reasons. So especially, when in different scenarios, there might be intermittent connectivity issues or network disruptions, which we mentioned. And that kind of leads to the connectivity concern. Edge computing overcomes the typical network limitations. We talked about those, right? Bandwidth, latency. But even the most, forgiving edge deployment will require some minimum level of connectivity, right? That connectivity has to be there. So it is critical to design an edge deployment that accommodates that poor or erratic connectivity and consider what happens at the edge when the connectivity is lost, because it'll happen. So that autonomy and AI and graceful failure planning in the wake of connectivity problems, they're all essential to successful edge computing. So you have to take all these things into consideration when you're designing and your project and the edge implementation. There are, of course, management issues, right? An important concern for companies facing is that sustainable management of these edge assets across multiple locations and devices in terms of their security, connectivity, their physical maintenance, those type of things. Some devices, right, there's this power cooling issues. The location of the equipment will be on pedestals and maybe some roadside walls, and that creates challenges with powering and cooling them, unlike a data center. That's kind of what we're used to. So the risk of using public spaces, right, to house edge equipment is another concern. So where you put your equipment in these public spaces and the challenges associated with it. And of course, the security, the physical and the cyber security. I actually heard about this Tesla charging stations that thieves basically stealing cables because they had copper in them. So this is happened 2-3 days ago in Northern California. So that's another thing, right? In addition to physical security implications, there's cybersecurity implications in terms of different attacks and DDoS and all those type of man in the middle, those type of cybersecurity implications, supply chain implications, because there's connectivity, maybe there's network, 5G, all those endpoint related attacks that might be another area of concern. And then we have IoT specific concerns because they're not secure by design, right? We have them in our homes and such. So that might be another area in terms of how you manage that whole life cycle of IoT devices, and based on policy-driven configurations, enforcements, and the connectivity issues. The infrastructure complexity challenges, I think, is another area. Setting up and managing a distributed, decentralized edge infrastructure across multiple locations. It can be a daunting, complex project and can be very resource intensive. Organizations need to deploy and maintain edge devices, gateways, and networking infrastructure. So, and then of course, as I mentioned, the data life cycles. I know we have some questions, so I'm just going to move forward. So the future trends, this is really all about creating value. Different industries use edge, leading the way with their innovation and the way they create service and products with their edge deployments. And there's more focus in terms of the strategic and broader implementations for edge networks for organizations. And of course, the ability to support AI. That's the latest trend. Technology with edge computing continues to improve because data is generated at the edge. And as you know, AI feeds on data. So technology packing more transistor into smaller pieces, smaller spaces for improved speed, efficiency, that's really important. And that's how we are able to now kind of bring the cloud's power, compute power storage to the edge. And these advancements in processing, special processing power, they let the organizations move AI capabilities into edge devices, reducing latency, reducing cost, and it opens a host potential of uses across various industries, from healthcare to manufacturing and retail. So every industry really benefits from it. And of course, there's that 5G in terms of how we're using 5G currently here in the US, in Europe, and there's that future aspect of 6G. It's really the latency issue, right? So 5G and 6G going forward, not anytime soon, but it does help in terms of reducing the latency by putting those compute resources close to the endpoints and allowing the connectivity issues. So I'm going to stop here. And I think we have some questions. Oh, one thing I mentioned is the number of devices and the volume, right? It's basically, as of 2024, it's 20 plus billion devices, connected devices, generating data, IoT and all such. And then 150 zettabytes of data generated. So again, and it's only going to increase, right? So that's why the combination of edge computing and cloud computing is very, very critical. So let's look at some questions. Okay, question one is how edge computing bridges the gap between benefits of cloud. So it's basically bringing the cloud, advantages of cloud to the edge where the data is created. So that's for question number. So that's how you combine them together, and that's allowing all the organizations really tap into the cloud advantages, the benefits, while reducing those latency and the bandwidth issues, and creating insights based on the data generated on-prem where the source is. Question two. What are some common challenges enterprise face adopting edge computing? So the challenges, believe it or not, they're all applicable to almost everything. Most of the time, it comes back to the resource issues, workforce skill set, right? Their culture might be an issue from time to right, mostly, but it's really knowing the environment. Vendor relationship is important, right? These are not things you'll be able to do. So you have to have a good third-party relationship. Risk assessment is important. So high level, how you do risk assessment, third-party vendor, how you deploy project program management. Change management is a big one, right? Because you go through this process, it's a change at the end of the day. So if you look at these issues, the team is really around people. So risk management, people issues, and cultural issues, resource issues obviously are there, but it's again applicable to most every other project that we have. So let's see, question three, how does security aspect differ from traditional cloud computing? And okay, so cloud computing is all centralized, right? And the edge is decentralized, as we've gone through. So there are benefits and pros and cons, actually. So you're in charge of the data. Security is all about data, as you know, right? So we have a couple of stuff. So where you do decentralized versus decentralized, it's really that data in transit being processed. So if when you're in charge of your data close and kind of can implement controls, that's kind of the pro, and you can do better when data is there at the edge where it's created versus you have to transfer it all the way to cloud. And of course, cloud service providers, they have their own security measures and features that are built in, but it's really getting the data from point A to point B where it's there out there, and you don't have really so much control. In terms of the measures, again, it's really knowing more, learning more about the difference of edge and cloud and how you can bring them together. So online learning, I think there are a lot of opportunities out there. Question four, any industry sectors well suited to benefit from it? Yeah, definitely. Healthcare, government agents, smart cities, I mentioned, manufacturing, retail. These are all different types of industry, farming, agriculture. Agriculture specifically is a big one, right? There's so much data. Nowadays, everything we do, doesn't matter the industry, everything we do touches on data, because data allows us to do all these things, to create the service, the value, the products. And to do that, we create lots of data. We have to analyze all that data, create those insights from all those data created from the edge devices, different types, right? And then essentially it needs to be kind of stored for long term. As I mentioned, processing power, cloud is our location. and how you kind of bring them together. So that's really the value we get from all these connections. With that, I think we're out of time. Nick, back to you. Thank you.
Great. Thank you again, Tall Guy, for such an incredible keynote. And I want to thank everyone else for joining us today. This session, along with all of today's content, will be available on demand following the event. For those of you who earned points throughout today's event, an Argyle team member will be following up with the winners in the next couple of weeks. This officially concludes the Argyle CIO Leadership Forum, Transformational Technology 2024. Thank you again for joining us today and engaging in our content. We look forward to seeing you at our next Argyle Digital Transformation Technology event soon, which will be our AI Decision Maker Summit, Revolutionizing Business Strategy with AI, on June 6th, 2024. Have a great rest of your day.